This is activity 1 from lesson 11. The title of lesson 11 is Writing Equations for Lines. And the activity 1 is coordinates and lengths in the coordinate plane. So we're going to start using the coordinate plane, the points within a coordinate plane, to figure out how do you write an equation, for example, for this line right here. But first of all, we have to learn how to figure out the lengths, the vertical lengths, and the horizontal lengths, and what is the relationship between these similar triangles. That will help us write the equation. So we're going to do this in two different ways. To figure out this length right here, and also we have to figure out what are the coordinates for point E. So what's the length of BE, and what are the coordinates for point E? Well, first of all, we know that these triangles are similar, and we've been over this. They have two pairs of congruent angles. This angle right here is shared between both triangles. I'm going to call triangle A in a moment and triangle B. So that's one pair of congruent angles, and the second pair of congruent angles is this 90-degree angle. So if you have two pairs of congruent angles between two triangles, those triangles have to be similar. It's because it forces this third angle to also be congruent, because this third angle has to add to 180 degrees. So these two triangles are similar, which means that we can use information from the larger triangle in this case to figure out what this unknown length is right here to get this information. And again, we're going to do that two ways. So first of all, we know that this length is 2 units, because along the x-axis it goes out 2 units. And we know that this length for the larger triangle, again, I'm going to call this triangle B, it's going to go out 4 units. So the x value for the larger triangle is 4 units. The x value for the smaller triangle is 2 units. So right away it has a relationship that the smaller triangle is 1/2 the length of the larger triangle. And to figure out the length, we know the length along the x-axis. To figure out the length along the y-axis, you have to subtract these 2 units. Remember, this triangle has been moved up the y-axis 2 units. We have to get rid of that 2 units right there. So if it's 7 units up to this point, you have to subtract the 2 units. And you're going to end up with this length right here of 5 units. So 7 units minus these 2 units equals these 5 units right here. So again, the relationship going from 4 to 2, 2 is 1/2 of 4. So this length right here is going to be 1/2 of 5. Let's just go through the idea of a dilation to prove that, to show you that. All right, so let's take this out of the coordinate grid for a minute. And this is the center of dilation. It's 0.02 on the coordinate grid. So this is the center of dilation. And the scale factor we know from these values right here. This value is 4 units for triangle B, the larger triangle. It's 2 units for triangle A. So that is 1/2. It's scaled down. It's decreased by 1/2. So 2 is 2, the ratio of 2 to 4 is 1/2. So that scale factor is 1/2. Well, if that's true, then 1/2 of 5 is going to give you this length. 1/2 of 5 tells you that that length is 2.5 units right here. So that's the method using the scale factor to figure out this length. So now we can do it another way. We can use the ratio of the vertical side to the horizontal side. So we know from before that if you take the ratio of sides within a triangle, that is going to be equal to that same ratio for a similar triangle. So this ratio, 5 units to 4 units, is going to be the same ratio for this length right here to 2 units. So for the larger triangle, that ratio is 5 units to 4 units. So this vertical length is 1/4 of 4, 1/4 of the horizontal length longer than the vertical length. Well, the horizontal length is 4 units. 1/4 of 4 is 1 unit. You add that 1 unit to 4 units this way, and you're going to get an answer of 5 units. So the vertical length is 1/4 of the horizontal length longer than the horizontal length, because it's 5/4. This ratio is 5 to 4. So the ratio within the triangle, the vertical side to the horizontal side. That means that the smaller triangle has that same ratio. So for triangle A, it's going to be this length, which is BE, to 2. Well, we know what that has to equal. It has to equal 5/4 because it's a similar triangle. So BE is going to be 1/4 of 2 longer than 2. So 1/4 of 2 is how much? Well, 1/4 of 2 is actually 1/2. Take 2 units, divide it by 4. 2 divided by 4 is 1/2. So this is 1/2. It's 1/4 of 2. This is 1 is 2/2. That's 1/2 of 2, or 2/4. This is 3/4 of 2. It's actually a size of 3.5, but it's 3/2, but it's 3/4 of 2. And 2 units is 4/4 of 2, and that 2 units is 4/2. All right, so you have the 2 units along the horizontal axis, and you have to add 1/4 of 2 to that. Well, 1/4 of 2 is that 1/2 unit. So 2 plus 1/2 is going to equal 2.5 units. It's the same value that we got when we use the scale factor. It's the same length. It's the same triangle. It has to be the same. Just 2 different ways of doing it. The first way was using the scale factor. The second way is using this ratio of sides within a triangle and applying that ratio to a similar triangle, which is triangle A in this case. So how do you figure out what the coordinates of point E are? Well, we know that the x value is 2 because it goes along the x-axis 2 units. And so this x value is going to be 2, the horizontal distance. But how far does it go up along the y-axis? So the first coordinate is the x-coordinate, that's 2. So what's this y-coordinate? How far does it go up? Well, this is 2 units, we already know that, to get to this point. And we just figured out this length right here. What's that length? That length is 2.5 units. So to go from the x-axis to the point, you have to go up this 2 units plus another 2.5 units. Well, 2 plus 2.5 equals 4.5 units. So this coordinate, the coordinates of this point E are 2 for the x value and 4.5 for the y value. Remember, that's this 2 units plus these 2.5 units for the y value. So you go along the x-axis 2 units, and you go up the y-axis 4.5 units, and you get to point E. So this is activity 1 from lesson 11.